The sharper-eyed viewers among you who watched the generating test data demo may have noticed that, even though I specified that I wanted compressed input data files to be generated, it appeared that standard text files were being created. You were correct! There were a few minor bugs in the GenTestFiles proc, and I thought I'd quickly go over the fixes and then run another test with much more data than the last demo. This time, we'll watch the Snowflake tasks being dynamically created in the queue schema, which is something we didn't see in the first demo. Looking at SB GenTestFiles map update, note that all parameters are passed as strings. One interesting thing I've noticed is that even though the parameter data types are char and varchar, I'm able to pass unquoted numerics and Boolean parameter values when I call the Snowflake JavaScript procedure. For instance, I will be calling this proc using the example in line 36, which will create 36 gzip files, each containing a month of daily data with 5,000 rows per day. See how, in this call, it wasn't necessary to quote string the char and varchar parameters. They'll be automatically converted to numeric and Boolean when referenced inside the proc. As mentioned previously, the parameter names must be referenced in uppercase. I'm also uppercasing the values of the typecode and compressed character input parameters for convenience. On line 134, I'm using the JavaScript match method on the string input parameter to determine whether gzip compression has been requested. I couldn't find any easy way to convert the input value to Boolean and trap a conversion error. This would be easy with a Snowflake SQL try-cast, and I could have called a Snowflake query to return the result, but this works. If the input parameter value matches any of the specified values, a compression variable is set for the file format and gzip is added to the extension for the Snowflake copy. I don't think this is technically necessary, as Snowflake auto compression detection will understand when a file is compressed during a subsequent load, but I thought it was cleaner to create the files this way. As we saw previously, the compression value is used in the dynamically generated file format definition on line 153. Another thing I didn't originally notice is that a partial file was always being created for the current month. So if I asked for 12 months of data, I'd get the prior 12 months plus the current month to date. It's not a big issue, but I thought it made sense to generate full months of data, so I modified the between clause in the CTE creating the temp tables to eliminate the partial current month's data. I came across one other issue, which took some debugging effort. After my code changes, I was getting an unknown identifier syntax error running the proc, which was generated in the catch block of the write proclog helper function. My theory is that some of my debugging log messages, which show object creation code containing single quotes, is throwing errors during the helper function parameter binding. Here's the proclog output for the most recent cycle. On line 5, the variable value which shows the dynamically created file format object used in the copy is being written to the proclog for debugging purposes. Notice the single quotes around string literals. I tried globally replacing single quotes with double quotes, but still had the problem. The simplest solution was to ignore any errors in the write proclog helper function, as I don't really care about errors in this routine. This fixed the problem, and interestingly, all of the write proclog calls in the proc are now being written to the log table. Go figure. This is a reminder of how stored procedure debugging in JavaScript stored procedures can sometimes be a challenge. I was able to save the procedure, but was getting an error when calling it. There was no output to the query history panel on the Snowflake console, and no output to the application's proclog table. I'll probably continue to investigate this to better understand what's going on and possibly develop some more advanced debugging tools. So let's start the second test demo, where we'll increase the volume to 3 years of daily insert data with 5,000 rows per day and monitor the dynamic tasks being created to process the insert jobs. Since this test will ideally want to run 36 concurrent tasks for the 36 months of data, we'll need to increase appconfig task max value from the current value of 10. We'll use sbset appconfig for that. Now, let's look at current system state before we generate the files and watch the processing. The TB map update staging table was emptied out at the end of the last update cycle. The map update stream was cleared at the beginning of the last cycle. And because the stream is empty, the stream has data attribute referenced by the map update start task returns false. The only task in the work queue is the persistent map update start task, which is always waiting for the map update stream to have data. The queue schema is where the Snowflake job processing tasks will be created during processing. It's currently empty. The pipe is running and ready for file input. And finally, the target table clone snapshot currently contains approximately 376,000 rows. Let's create some data and watch it get processed. We'll start by calling GenTestFiles map update to generate the 36 months of daily insert data, 1 month per file, with 5,000 records per day, compressed as gzip files. We'll be using the queries below to monitor processing while it's in process. As mentioned in this demo, we'll be using the show tasks with the in option to view tasks which have been dynamically created in the queue schema to process the months of input data. The -1 return indicates that it completed successfully. And by the way, I cheated a bit in this demo. It did take a few minutes to execute. Over in the Azure Explorer, let's see what was generated. Here are the zipped data files. Now we'll monitor processing. The start task has been waiting for all of the files to be processed and the pipe to be without any pending files. Processing is underway. We're in the middle of the start processing. The job and task tables are being populated. There are 5,480,000 rows in the TB map update table. Here are 10 rows from that table. Here are 10 rows from the view off that table. The stream has been emptied out by the start processing, so it currently contains no data. Here's the job task view, which shows all of the jobs that are waiting to process. As we can see, 36 months, 36 jobs for 36 months of data. Currently, in the work schema, the start process is waiting with no data to process, and the process task is currently executing. We're starting to build up tasks in the queue schema. The log shows that we're continuing to spawn off tasks to process our jobs. All 36 update jobs have completed. We'll be switching over to the end processing. And now, in the target table, post-update, we have 5,491,000 rows. Here's some of those data. We've just given the system a very good workout. Before we finish up, I wanted to show you some account level queries available in the Snowflake account usage schema. By default, this schema is only available from the account admin role. If you recall, in the processing overview, I mentioned that the stream has data function referenced in the map update start task executes in the cloud services layer and doesn't accrue compute credits. Let's verify that. The first query shows the daily counts for the executions of the map update start tasks between June 10 and June 20. This task is scheduled to run every minute. Note, every day has executions. This query shows the compute and cloud services credit usage by day for the same date range. Note that there are gaps where there are no credits used. These are the days where there were no update cycles being run, but the map update start task was still running for free. The final query shows storage usage. Note how data which is beyond the retention date is still available for recovery via Snowflake failsafe.